Hello students, in continuation of our discussions on motion in a plane, today we will discuss about uniform circular motion, which is section 4.11 of chapter number 4 of physics for class 11. When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. The word uniform refers to the speed which is uniform, that is constant throughout the motion. All the points discussed in this section are important. Please note down as these will help you in your examinations. I welcome you once again. Uniform circular motion. A particle is in uniform circular motion if it travels around a circle or a circular arc at constant or uniform speed. So, uniform circular motion exists if a particle travels around a circle, as shown in figure, the left hand side. Although the speed does not vary, if you observe here, the magnitude of the velocity or the speed remains constant, but the particle is accelerating due to change in direction of velocity. So velocity is varying in direction, as you can see the difference between velocity at A and velocity at B. Displacement and distance. When particle moves in a circular path describing an angle theta as shown in the figure during the time t from position A to position B, we see that the magnitude of the position vector r, which is equal to the radius of the circle, remains constant. So radius of the circle is constant even though the particle has moved from A to B because of circular path. Therefore, the mod of R1 is equal to mod of R2 equal to R, the radius of the circle, and the direction of the position vector changes from time to time. Displacement. The change of position vector or delta R, the displacement of the particle from position A to position B, is given by referring the figure. So here it is delta R. Delta R is R2 minus R1. Distance. The distance covered by the particle during time t is given as S is equal to length of arc AB. Angular displacement theta. The angle turned by a body moving on a circle from some reference line is called angular displacement, and it is represented by the symbol theta. Dimensions of angular displacement are m to the power of 0, L to the power of 0 and t to the power of 0. Please note here all are zeros, so to the power of zeros, as theta is equal to arc of a circle divided by radius. So hence the term L also is 0. Units of angular displacement are radians or degrees, or sometimes it is also given as number of revolutions. And in revolution, 2 pi radians is equal to 360 degrees. Angular displacement is an axial vector quantity. Its direction depends on the sense of rotation of the object and is given by the right hand rule. Relation between linear displacement and angular displacement. So angular displacement S is given by R is the radius into R cross theta. All the three items are vectors. R S is equal to R theta. Angular velocity omega. Angular velocity of an object in circular motion is defined as the time rate of change of displacement. That is, angular velocity omega is given by angle traced divided by time taken. That is also given as limit as delta t tends to 0 d delta theta by delta t. That is limit of delta theta by delta t as delta theta tends to 0. That is simplifying the first differential of theta, that is d theta by dt. Dimensions of angular velocity omega are m to the power of 0, L to the power of 0, t to the power of minus 1. Units. Unit of angular velocity omega is radians per second. That is radians per second or degrees per second. Angular velocity is an axial vector. Its direction is same as that of delta theta. Relation between angular velocity and linear velocity. It is given by V is equal to omega cross R. For uniform circular motion, omega remains constant. That is, angular velocity remains constant, whereas for non-uniform motion, angular velocity varies with respect to time. Change in velocity. We want to know the magnitude and direction of change of velocity of the particle which is performing uniform circular motion as it moves from point A to B during the time t as shown in the figure. The change in velocity vector is given as delta v is equal to vector v2 minus vector v1. That is equal to 2v into sine theta by 2. Time period t is defined as the time taken by an object to complete one revolution on its path. That is, the time taken to complete one rotation of a circle is the time period capital T. Frequency represented by n. In circular motion, the frequency is defined as number of revolutions. Please note, it is number of revolutions completed by object on its circular path in unit time. That is, it is number of cycles per second. Its unit is cycles per second or C/S or hertz. We use these terms very frequently in AC circuits and radio communication, wireless communications. Dimensions of frequency are m to the power of 0, L to the power of 0, t to the power of minus 1. Because it is cycles per second. Per second is t to the power of minus 1. Relation between time period and frequency. We know time period is represented by capital T. So the relationship is capital T is equal to 1 by n. Sometimes instead of n we use the letter f also. Relation between angular velocity, frequency and time period. Angular velocity we know is omega. Omega is equal to 2 pi divided by t. that is equal to 2 pi n. 2 pi into number of revolutions. Angular acceleration alpha is equal to angular acceleration of an object in circular motion is defined as the time rate of change of its angular velocity. Therefore, alpha is given by limit of delta omega by delta t as delta t tends to 0, that is equal to d omega by dt, that is equal to second order differential of theta, that is d squared theta by dt squared. This is in differential form. So unit acceleration alpha is radians per second square, and its dimension is m to the power of 0, L to the power of 0, t to the power of minus 2. Relation between linear acceleration and angular acceleration. We know linear acceleration is represented by the letter small a, that is equal to alpha vector alpha, which is angular acceleration into radius of the circle r. So a is equal to alpha into r. For uniform circular motion, alpha equal to 0, that is alpha is equal to d omega by dt is equal to 0. For non-uniform circular motion, alpha is not 0. After defining centripetal acceleration, we now move on to define centripetal force. Please see the diagram here, shown here. The above referred figure shows the relation between velocity v and acceleration vector a at various stages during a uniform circular motion. So here the object is performing a uniform circular motion, and at certain points we will define v. Both vectors v and a acceleration have constant magnitude. The magnitude does not change as the motion progresses, but their directions are changing. You see, the direction of v is vertically downwards and acceleration is in the left side. Similarly, at this point, the direction of v on the right hand side and acceleration is downwards. And at this point, velocity is vertically up and acceleration is on the right hand side. In the fourth point, acceleration is upward, velocity is on the left side. So their directions are changing continuously. The velocity is always directed towards a tangent. The velocity points here at different 4 points are tangent to the circle in a direction of motion. The acceleration is always directed radially inwards. Because of this, the acceleration associated with uniform circular motion is called centripetal, meaning center seeking. So acceleration is always directed center seeking direction. The center seeking force is called the centripetal force. Hence, centripetal force is that force which is required to move the body in a circular path with uniform speed. The force acts on the body along the radius. This force acts on the radius side towards its center. The magnitude of this acceleration is given by A is equal to V square by R, where R is the radius and V is the speed of the particle. The period of revolution is given by T is equal to 2 pi R by V, that is velocity. Now we will specify some examples of centripetal force. In column 1, examples are given, and column 2, the centrifugal force acting on it. A particle tied to a string and whirled in a horizontal circle is due to tension in the string. A vehicle taking a turn on the level road experiences a centripetal force due to friction exerted by the road on the tire. A vehicle on a speed breaker experiences the centripetal force due to weight of the body or a component of the weight. The revolution of Earth around the Sun is due to gravitational force exerted by the Sun. The electron revolving around the nucleus in an atom is due to attraction, Coulomb attraction exerted by protons in the nucleus. Finally, a charged particle describing a circular path in a magnetic field experiences a centripetal force due to magnetic force exerted by the agent that sets up magnetic field. Formula for centripetal force. F is the centripetal force. The force is given by the relation mv square by r, where m is the mass and v is the velocity, r is the radius. That is, can also be expressed as m omega square r in terms of angular velocity omega. That is equal to m into 4 pi square n square r. That is, omega is equal to 4 pi n, 2 pi n. That is equal to m into 4 pi square divided by t square into r. Centrifugal force. We also have another force called centrifugal force, which is an imaginary force. Centrifugal force is an imaginary force due to incorporated effects of inertia. Centrifugal force is fictitious force which has significance only in a rotating frame of reference. The work done by centripetal force is always zero, as it is perpendicular to velocity and hence instantaneous displacement. Let us solve some problems associated with projectile motion and uniform circular motion. Problem number 9. A cricket ball is thrown at a speed of 28 meters per second in a direction 30 degrees above the horizontal. Calculate the maximum height, the time taken by ball to return to the same level, and C, the distance from the thrower to the point where the ball returns to the same level. So these are the simple problems. We have to remember formula and substitute it. Maximum height is given by hm is equal to u sin theta square by 2g, where u is the initial velocity and theta is the angle thrown of the projected and g is the gravitational force. So it is given, u is given as 28 meters per second. It is given here 28, and sin theta is sin 30 degrees. 30 angle is also given. 2 into g whole square. We have to write whole square. So we know 28 sin 30 is 1 by 2. So therefore 1 by 2, 28 into 1 by 2 is 14. 14 square is 14 into 14 divided by 2 into the value of g is 9.8 meters per second. Therefore, simplifying, we get that is equal to 10 meters. So h height, maximum height is 10 meters. Part B. Time to return to the same level is given by the relation, that is flight time Tf is equal to 2u sin theta by g. Therefore, that is equal to 2 into u is given as 28 meters per second into sin 30 divided by 9.8. That is the gravitational force. Simplifying, we get sin 30 is equal to half. We get 28 by 9.8. That is equal to 2.9 seconds. Part C. The distance from the thrower to the point where the ball returns to the same level is given by the relations range, that is r is equal to u square sin 2 theta by g, that is equal to u is given as 28 meters per second, 28 into 28 sin 2 into 30, theta is 30, 2 into 30 divided by 9.8. So this is sin 60 and we have to substitute the value of sin 60. So simplifying, we get 69 meters. So the distance of the thrower where the ball returns is 69 meters. Problem number 10. An insect trapped in a circular groove of radius 12 centimeters moves along the groove steadily and completes 7 revolutions in 100 seconds. Part A. What is the angular speed and linear speed of the motion? Part B. Is the acceleration vector a constant vector? What is its magnitude? Please read the problem again and analyze. So radius of the trap circular groove is 12 centimeters. Let us solve it. Given r is equal to 12 centimeters and number of revolutions is 7 and time is 100 seconds. So therefore omega, angular velocity omega is equal to 2 pi by t. This we have done the derivation, that is equal to 1 by t is n, that is equal to 2 pi n. Sometimes some books to write it as f, 2 pi f. Anyway, we are using 2 pi n. Therefore, that is equal to 2 into pi into 7 by 100. That is n is 7 by 100. In 100 seconds, it makes 7 revolutions. Therefore, simplifying, we get the value of omega as 0.44 radians per second. So, linear speed v is, as the relation is given by equations, v is equal to omega into r, that is equal to omega is equal to 0.44. We have calculated in the previous step. 0.44 into 12, that is equal to 5.3 centimeters per second, because r is in centimeters. Part B. The direction of velocity v is along the tangent to the circle at every point. The acceleration is directed towards the center of the circle. This is also very clearly explained in the previous slides. Since this direction changes continuously, acceleration here is not a constant vector, because direction is changing, velocity is changing, so also the acceleration. However, the magnitude of acceleration is constant and we have to calculate the magnitude. Acceleration is equal to omega square r. Omega is equal to 0.44 square into 12, that is equal to 2.3 centimeters per second. In this section, we will answer short answer questions which will have 1 or 2 marks in your class examination. Question number 1. Under what condition is the average velocity equal to the instantaneous velocity? The answer is when the body is moving with a uniform velocity, the average velocity will be equal to the instantaneous velocity. Question number 2. Suggest a situation in which an object is accelerated and has constant speed. Answer. When the object is accelerated and has an constant speed, then the motion is uniform circular motion. Question number 3. What is the angle between velocity vector and acceleration vector in uniform circular motion? That is, answer is the angle between the velocity vector and acceleration vector is 90 degrees in the case of uniform circular motion. Question number 4. A particle is in clockwise uniform circular motion. The direction of its acceleration is radially inward. If the sense of rotation or particle is anticlockwise, then what is the direction of its acceleration? Answer. When the sense of rotation is reversed or is anticlockwise, even then its acceleration is radially inward. The acceleration is always towards radially inwards in case of a uniform circular motion. Question number 5. What is the average value of acceleration vector in the uniform circular motion over one cycle? The average value of acceleration vector in uniform circular motion is always a null vector. Question number 6. Does a vector quantity depends upon frame of reference chosen? No. The vector quantity does not depend on the reference chosen, frame of reference chosen. Question number 7. What is the angular velocity of an hour hand of a clock? Answer. The angular velocity of a clock is given by the relations omega equals 2 pi by 12. This is the angular velocity of a hour hand because there are totally 2 pi radians circular motion and there are 12 hours. Therefore, angular velocity omega is equal to 2 pi by 12, that is equal to pi by 6 radians per hour. Question number 8. What is the source of centripetal acceleration for Earth to go round the Sun? Answer. The source of centripetal acceleration for Earth to go round the Sun is the gravitational force of Sun. Question number 9. A cyclist starts from center O of a circular park of radius 1 kilometer and moves along the path OPRQO as shown. If he maintains constant speed of 10 meters per second, what is his acceleration at point R in magnitude and direction? The answer is the centripetal acceleration is given by the relationship AC equals V square by R, where AC is the centripetal acceleration, V is the velocity and R is the radius. So it is given that the velocity is 10 meters per second. So V square is equal to 10 square and radius is 1 kilometer divided by 1000 meters. So 1 kilometer is converted into meters, 1000 meters. That is simplifying, we get the answer as 0.1 meters per second square along the direction RO. Question number 10. Is the acceleration of a particle in circular motion not always towards the center? Explain. No, acceleration in the case of a circular motion is always towards the center only in the case of uniform circular motion. Question number 11. It is a long answer type question. It will carry 5 marks. It is a derivation of an expression for centripetal acceleration of a particle moving with a constant speed v along a circular path of radius r. And we are also required to define centripetal acceleration. Answer. Centripetal acceleration is the acceleration of a body traversing a circular path. When a body travels on a circular path, its direction constantly changes and thus its velocity changes, producing an acceleration. Please see the figure here. This is a body is moving along a circular path. O is the origin or center of a circle and theta is the angular displacement, angle of displacement. Consider an object in uniform circular motion making an angle delta theta in time delta t. Therefore, angular speed omega is given by delta theta by delta t. There, but v is equal to velocity v is equal to delta s by delta t, where delta s is the displacement or angular arc of a semicircle. Therefore, delta s is equal to r, v is equal r into delta theta. Therefore, v is equal to r into delta theta by delta t. Substituting for delta s, we get delta s is equal to v into delta t. So, therefore, v is equal to r into delta theta by delta t. That is equal to r into omega, because delta theta by delta t is omega. Therefore, centripetal acceleration AC is equal to v square by r, where v is the velocity and r is the radius. Therefore, AC is equal to, substituting for v as omega r, we get v square is equal to omega square into r square divided by r. So, one r in the denominator gets cancelled with r in the numerator and we get omega square r. We will solve two numerical problems before we conclude this lecture. Question number 12. A stone tied to the end of a string 80 centimeters long is whirled in a horizontal circle with a constant speed. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? Answer. We know that angular velocity omega is given by the relation omega is equal to 2 pi by t. That we can write it as 2 pi into n by t, because there are number of revolutions where n is the number of revolutions and time is the total time. Therefore, omega is equal to 2 pi n divided by t, that is equal to 2 into pi into 14 divided by 25, that is 14 revolutions it is given in 25 seconds. So simplifying, we get the answer as 88 radians, 88 by 25 radians per second. Further continuing, we also know that the centripetal acceleration I suffix c is given by the relation AC is equal to omega square into r, where AC is the centripetal acceleration, omega is the angular frequency, and r is the radius. Therefore, putting the value of omega as 88 by 25, we get omega square is 88 by 25 whole square into r. R is 80 centimeters. It is given in the question. Therefore, simplifying, we get the answer as 99.123 centimeters per second square. Next question, question number 13. A cyclist is riding with a speed of 27 kilometers per hour. Please note the speed is 25 kilometers per hour. As he approaches a circular turn on the road of a radius 80 meters, he applies brakes and reduces his speed at a constant rate of 0.5 meters per second square. What is the magnitude and direction of the net acceleration of the cyclist on the circular turn? Please observe here, read the question once again. It is speed is 27 kilometers per hour. Let us solve it. Therefore, the answer is, it is given speed as 27 kilometers per hour. We have to convert kilometers per hour into meters per second. Therefore, V equals 27 kilometers per hour equals 27 into kilometer into meter we have to convert. So, we have to multiply it by 1000. 27 into 1000 per hour means we have to convert it into per second. So, we have to divide it by 60 into 60. So, that becomes, simplifying, we get 7.5 meters per second. The first 60 is for converting hour into minutes and minutes into seconds. So, answer is V is equal to 7.5 meters per second. Therefore, centripetal acceleration AC is equal to, we know the formula, V square by R, where V is the velocity and R is the radius. So, we have got V is equal to 7.5 meters per second, that is equal to 7.5 whole square divided by R is 80. Simplifying, we get 0.7 meters per second square. Therefore, tangential acceleration, it is given tangential acceleration as 0.5 meters per second square. It is given in the question. So, therefore, net acceleration is given by the formula A is equal to square root of AC square plus AT square. That is the vectorial addition. Magnitude is A is equal to square root of AC square plus AT square. That is, we know AC is equal to 0.5 meters whole square plus AT is 0.5 meters. Therefore, it is substituting and simplifying, we get the answer as square root of 0.74, that is equal to 0.86 meters per second square. Now, we can also find the angle, the direction of a net acceleration. If theta is the angle between the net acceleration and the velocity of the cyclist, then we know the relation tan theta is equal to AC by AT, where AC is the centripetal acceleration, AT is the tangential acceleration. That is equal to 0.7 divided by 0.5. That is simplifying, we get the answer as tan theta is equal to 1.4. Therefore, theta will be equal to tan inverse of 1.4. So from tables, if you refer, you will get the answer as theta equals 54 minutes and 28 seconds. With this, we have concluded our discussions on uniform circular motion. In the next lecture, we will revise or summarize whatever we have learned in chapter 3 and 4, and we will also solve some exercise as well as numerical problems. Till then, goodbye.